So we made predictions. Then we sent the crystals to a well-recognised laboratory who was well known for doing that work, to actually measure the rate of leakage. And where did it fit? Exactly on the 6,000 year prediction. In other words, while the uranium to lead clock had ticked at the rate of 1.5 billion years, that's 1,500 million years, while uranium had been ticking through that rate, helium had been leaking at a different rate. That means, because we know of the law of leakage of these atoms, well-known physical law that we can reproduce in the laboratory, that was a far more credible age determination method.
There was some basalt flows that erupted on the rim of the Grand Canyon, flowed down into the canyon all the way to the base of the canyon. That means that the lava flow is younger than the canyon, younger than the uppermost sediments, and yet that lava flow dates to millions of years older than the canyon itself. It really raises the question, how do we know that these techniques are valid?
We've got other lines of evidence. There was about 3 or 4 lines of evidence that we found that all pointed in the same direction, that the assumption of nuclear decay rates always being constant at the rates we measure today isn't true, that they were accelerated in the past, and that means the clocks can't be trusted.
We have done carbon-14 dating on coal and diamonds, which are hugely old. Diamonds are supposed to be over 1 billion years old, and yet we find carbon-14 in them. Now, hang on, carbon-14 would have long just decayed if it were that old.
One of the